All right, I started out by asking you the difference, or if you could draw 1 inch, a square inch, and a cubic inch. That's what I asked. All right, so let's take a look. If I ask you to draw an inch, you should have drawn something like that. If I ask you to draw a square inch, you should say it looks something like that. Now, of course, I don't really care how perfect it is. All right, but it should represent what? It should represent kind of like a square. All right, and then if somebody said, give me an example of a cubic inch, you should have been able to draw a what? A cube. That's exactly right. And if you understood that, or if you did that, you have a pretty good idea of the difference between an inch, a square inch, and a cubic inch. All right, so just as a visual here, you would simply, say, all right, you would say that this measures length, this measures area, and this measures volume. All right, we measure what's inside a room with cubes. How many cubes can fit in there? On a surface, we say how many squares can fit on that surface. And if you want to know how tall something is, you measure its length. All right, so those are the 3 most important things that you should be able to tell somebody now. All right, and most people, believe it or not, hard to believe, don't know the difference between an inch, a square inch, and a cubic inch. All right, and it doesn't matter if it's a foot, a square foot, a cubic foot, whatever units. All right, you have to understand that I'm trying to figure out how many of these cubes, I'm trying to figure out how many of these cubes fit in each one of these shapes. That's what I'm trying to calculate. How many cubes fit inside? All right, and of course there's just a what? Formula for it. All right, the formula they figured out. All right, so what I want you to do now is, I want you at the top of your page, I want everybody to write down capital V. V stands for what? Volume. All right, then the formula goes something like this. It is simply capital B times capital H. That's how simple finding volume is. Now, what exactly does capital B stand for? Capital B does not stand for base. It stands for area of the base. Stands for area of the base. Now, how many different types of bases can you have in a prism? A lot. It can be a circle, it can be a square, it can be a rectangle, it can be a triangle, it can be a trapezoid. All right? The prism is just the general shape. All right? It just means it's a 3-dimensional shape. Now, a prism has 2 bases, we say, and they're always parallel to each other. All right? And they're always exactly the same. All right? So the area of the base, capital H, stands for what? The height. The height of what, though? The height of the prism. The height of the prism. And the reason why I'm telling you that is because there's the height of the base and there's the height of the prism. All right? Different things. And that's why I need you to really pay attention, because all of these formulas are very simple. All right? Tomorrow we're going to do maybe cylinders, and then we do pyramids, then we do cones. And there's an overwhelmingly number of formulas. And if you try to memorize all the formulas, it's just not going to work. That's why we break it down into a single formula, and we explain to you exactly how we get that formula. All right? So, again, the formula that you're going to be writing down is volume equals base times height. Now I'm going to look at question number 1. what would we call that shape? That is called a what? That is called a rectangular prism. The reason why it's called a rectangular prism is because the base is a what? The base is a rectangle. Just like number 2, that's called a what? Triangular prism. All right, it's called a triangular prism because the base is a what? The base is a triangle. All right, now, I want to ask you a question. Does the prism always sit on its base?
No.
No, and we can see that right in question number 2. This right here, is that the base?
No.
That is not the base. The base is the 2 sides that are parallel to each other. And if I move this over, you will see it's what? Same exact. So the base is always parallel to itself. And it is exactly the same shape. That's how I know this down here is not the base. It's not the base. What?
Can you do that like with the angle thing in the air? Like that line and that. Like with the so it's 90 degrees.
Yes. Right. Yeah.
And it points to the
That's a very good thought. And the answer is no. All right. And the reason why I'm saying no is because the height is always going to be perpendicular. That is true. All right. So you could almost establish, but to me the easiest way to do it is to say, okay, these are the 2 bases. What's the distance between those 2 bases? All right. What's the distance between those 2 bases? The distance between those 2 bases is this length right there. That's what I want you to think about. You are 100% right, though. This points to the base and the height. They don't always put the shape there like they do for the triangle. Okay? Now, I want to go back to number 1 for just a minute. Number 1 is unique because this is definitely the base. Would you agree with that?
Yes.
Right? It's parallel. Now you have to pay attention for a quick second so I can explain something. Could that be the base?
Yes.
Yeah, so the rectangular prism is unique because it's parallel. All sides, opposite sides are always parallel in the rectangular prism. So does it matter which one you call the base for the rectangular prism? And the answer is no. All right? You could say this right here is the base. You could say that that's the base. You could say that the back wall is the base. All right? That's the only shape that works for, though. All right? Now, please listen to me because now we're going to go ahead and get into the formula. All right? So, again, the shape we said was a rectangular prism. You wrote that down. Now, the volume, I want everybody to write down volume equals capital B times capital H. Somebody tell me, what is the base of this shape again? What's the base shape?
It's a rectangle.
Rectangle. So what's the formula for finding the area of a rectangle? Base times height. Now notice I did little b, little h, and then capital H. So you have to understand the difference between the lowercase. You have to understand the difference between the lowercase letters and the uppercase. Lowercase letters are referring to the actual what? Base. The capital letters are actually referring to the prism itself. Is everybody with me? So you got to listen to me now, or it's going to be a blur. All right, so now, what would you say the base and height are of the rectangle? Say 4 and it doesn't really matter, but for me right now I said this was the base. So what?
Okay, so 4 times 7.
4 times 7. But she is correct. It doesn't really matter on the rectangle, but it does matter on the triangle. All right, so we're going to do 4 times 7. And then what's the height of the prism? 11. All right, so I want everybody to do on their calculator now 4 times 7 times 11. And somebody tell me what that is. Is it 308?
Yes.
Now we're going to say 308
Thank you.
feet cubed. 308 feet cubed. Is everybody okay with that? Any questions?
You want us to fill out the shape?
Yes, I want you to write rectangular prism. Just like number 2, I want you to write what?
Triangle.
I want you to write triangular prism. All right? And the reason it's called a triangular prism is because the base itself is a what? The base itself is a triangle. So now, everybody has to write the formula. First formula to write down is volume equals what? Capital B times capital H. That's what everybody's writing down. Capital B times capital H. Then, after you write down capital B, capital H, I want you to write down that the base is a what? Triangle. So you have to be able to now tell me what the formula for area of a triangle is. So volume equals capital B, capital H. Area of the base, tell me.
1/2 each.
Yes. Yes. So you would say 1/2 lowercase b, lowercase h, capital H. So the capital H refers to the height of the prism. Lowercase h refers to the height of the base. And the base this time is a triangle. So here we go. So I want V. What's the base of the triangle? Somebody tell me. 26. What's the height of the triangle? And what's the height of the prism? That is awesome. If you know that, you're in great shape. And I told you it's simple. All right, now multiply that out for me. $900 what?
24.
Anybody else agree with that? And then we would say meters cubed. Okay, Jack, where's your calculator? Okay. You can't just sit there. All right? I'm asking you to plug the numbers in. All right? Doesn't make any sense to me. All right, where's your calculator? All right. So, anybody have any questions with that? Anybody have any questions? I want to leave him alone. I want him to work. You don't need to be sharing. All right? All right, now, I want everybody to take a look at number 3. What is number 3 called again? Rectangular prism. Number 4 is called a what? Triangular prism. So I want someone to tell me the base and height of the base. What is the base and height of the base?
8 and 4.
And what's the height of the prism? Beautiful. Number 6 is called a what? Rectangular prism. Number 6. Triangular prism. Okay. Now, I'm going to move on because there was one that somebody said that didn't look very good. Okay, I want everybody to look at question number 11. All right, I think they didn't make a mistake on this one. They just didn't make it very clear. Everybody look at number 11. All right, the reason why they didn't make it very clear is because they didn't put the right angles in here. All right, they didn't put the right angles in here. They should have made a right angle down here, so you could see that it's still a rectangular prism. All right, but why does it look not correct? Who can tell me what the problem is, Tucker?
Well, it looks like 30 and 19 on the same side.
Yes, exactly. Is that possible? No. It's not possible. So when someone asked me, is there a mistake here? I was like, okay, it looks like there's a mistake, but you should be smart enough to figure out that what does 30 probably represent? What does 30 probably represent, Xavier? Yeah, so this 30 looks like, to me, it should be right there. Or you could say it looks like it should be that length right there. Then do we have all the information that we need? Yeah, because to me, obviously to me, 19 millimeters looks like that's the height of the prism. Is everybody with me on that?
Yeah.
All right, so when something doesn't look right, maybe you should be smart enough to say, okay, well, I know 30 can't be the height, both height and 19 both be the height. Does that make sense, guys? All right, so I think everybody understands what I'm getting at. All right, now what I want to do is, for question number 13, I just wrote something without drawing the what? It just didn't write the picture, that's all. All right, now what I want to do is I want to go to number 15. All right, so here is the most important part of it. All right, so this obviously looks like the outline of some type of house, maybe, right? And what we want is we want to try to figure out this volume. Hey, why don't you seriously just bring that over here? It's okay. Don't worry about it. Okay. All right. So what you're supposed to do now is you're supposed to look at that and say that is a composite figure, and it's made up of what? It's just made up of a triangular prism and a rectangular prism. So does the volume formula change? No. All right. It's still going to be, listen to me, it's still going to be the area of the base. That is the base right there. All right. So I know some kids that might say, well, can I just make it a triangle and a prism or a triangle and a rectangle and then add it up? I'm going, yeah, okay, do that. All right. But I also would like you to say, okay, that makes sense. The base is simply a rectangle and a what? Triangle. That's it. All right. So what I'd like for you to do is I'd like for you to say the volume again is capital B times capital H. All right. Then I'd like you underneath that to write volume is equal to, well, we have a triangle. What's the formula for area of a triangle? Tell us.
1/2 BH.
1/2 BH. Then we have a rectangle. What is the formula for area of a rectangle? I'm sorry. Mr. Thatch, tell me. Base times height. Now, what do you think we have to do to those two areas? You add them together, right? I'm going to add them together, and then I'm going to multiply that by
the height.
The height. That is it, guys. Now look at that formula, guys. The average kid would go, oh my gosh, that looks so complicated. It's not complicated if you understand how we're creating this. All right, not at all. All right, the volume is simply the sum of the two shapes, the area of the two shapes multiplied by the height. All right, that's how I would like for you to see it. All right, now volume equals parentheses 1/2 times, what's the base of the triangle? Tell me. 20. What's the height of the triangle? 8. Plus, what's the base of the rectangle? And what's the height of the rectangle? And then what's the height of the prism? That's how simple this problem is, guys. Now, last time I got frustrated with some of the kids because they're just not typing the numbers into the calculator. Don't wait for somebody else. Does your calculator have parentheses on it?
Yes.
Yeah, use the parentheses if you want. All right? Use the parentheses. The calculator does the order of operation. Hit equals at the end.
8,960.
Somebody said the volume is 8,960. Is that what you said?
Yeah.
And this is feet cubed. How many sides does this have? How many sides does the base have?
6. No. 4.
Think for yourself. Come on. Can we just not count by ourselves? How many sides does this have? Wow, maybe I'm wrong. Xavier, what do you think?
I think it has 7.
7. I don't know why everybody's counting. Can we not count 5 together here? I don't understand what you guys are doing. I said the base. Here we go. Let me. Yeah. You don't have to explain to me. I'm asking you to count to 5 here, and some of you are having trouble.
Wait, it's 9 though.
What are you talking?
9.
Don't even. You don't even have to try to explain to me how you got 9. That's not even possible. So stop. No, I'm telling you, if you're counting 9, I'm questioning your ability to count from 1 to 5. 1, 2, 3, 4, 5. There are 5 sides to the base. And does anybody know what 5 sides is called?
Pentagon.
Pentagon. So we call this a pentagonal prism. Pentagonal prism. Do I really care if you understand pentagonal? No, I want you to know something has 5 sides. It's called a what? Pentagon. All right? But formally, that would be called a pentagonal prism because the base is a pentagon. Listen to what I'm saying. The base is a pentagon. All right? It doesn't matter. All right? I don't even care. That's not even going to be on the test. All right? What is critical is this information right here. If you understand this information, you are in actually very good shape. All right? You're in very good shape. All right? So now I'm going to scroll down. All right? And we're going to take a look at this. Now, this one. All right? This right here. In my opinion, it's easier just to think of this as 3 what? Yeah, 3 rectangular prisms. I don't really feel like calculating the area of the base. All right? Because calculating the area of the base wouldn't be that difficult. But I'm trying to show you this right here. Hold up so you can follow me. Does everybody understand? That right there would just simply be the area of the base, correct? And that area is just made up of 3 what? It's just made up of 3 rectangles. All right? So some of my kids said, well, can I just find the volume of that, find the volume of that, and find the volume of that? And then what do I do with those 3 volumes? Yeah, come on, let's not make that hard. That's easy. All right, so make yourself a note of that if you're not sure. All right, now what I want to do is I want to look at this one down here. Because again, most people see that as 3 shapes. Personally, I see it as just 2 shapes. What shapes do I see? Can anybody tell me? What do I see?
You see a pentagonal prism.
Yes, that's exactly what it's. Well, no, yeah, well, 1, 2, 3. Yes, pentagonal prism. But what is the prism made up of? What 2 shapes? You are correct. It's a pentagonal prism. What are the 2 shapes made up of? Tell us.
Rectangle and triangle.
I don't like it.
Triangle and trapezoid.
Yay, that's exactly correct. This is what I want you to see. Can you do 2 triangles and a rectangle? I'm totally fine with that. You're not going to be wrong. All right, you're not going to be wrong, but I'm trying to get you to visualize something, so please look. All right, watch the visual here. We're going to create this here. This right here is how I'm seeing it. That shape is a what? Trapezoid. And then, of course, this shape right here is the what? That is the triangle. All right? And those composite shapes make up the pentagonal prism. All right? So now we're going to do volume again. I want everybody to make it nice and big. I want to make sure that you're understanding what I'm saying. Volume is equal to area of the base times the height. Volume is equal to area of the base times the height. All right? Now, again, I want someone who remembers the formula for area of a trapezoid. Tell us, Sean. Times? Yes, there you go. Beautiful. So now I want V equals parentheses. Now I have 1/2 parentheses B1 plus B2 times little h plus What's the formula for area of a triangle?
1/2.
Yes, 1/2 base times height. Now, again, I'm trying to get you to understand why I'm making you write this out. I'm making it write it out, make you write it out, so when you take your ERBs, you'll remember. All right? That's what you're supposed to be doing. You write it out, write it out, write it out, write it out. And eventually it'll stick into your long-term memory. All right? This is a hard thing. I personally don't think it's that hard if you understand the formulas. All right? Now, here we go. Again, we're going to write volume equals parentheses 1/2. What is or what are the two bases of the trapezoid? Tucker, come on.
Isn't it 4.5 and 4.5?
No.
Well, 4.5 is one of them.
4.5 is one of them. Tell me.
2?
No.
Oh.
What?
Is it 6.5?
Yeah, of course, 6.5. Now I'm just going to draw this out so you can see it. Right? This right here is one base, and this is one base of the trapezoid. Does everybody see that, right? Now, what's the height of the trapezoid, someone?
The height is... It's...
Yes,
Yeah.
3, of course. 3 plus. Now I want everybody to look at the triangle. I want you to tell me what the base and height of the triangle is. Tell us. You.
So the height of the triangle is 1.5.
And the base is?
And the base is 4.5.
You're awesome. 4.5 times 1.5. Now I close the parentheses. And someone tell me, here's the hard part. What is the actual height of the prism itself? What do you think?
4.5?
Is the height of the prism 4.5?
Yes.
What do you think? 2. Now, how do I know it's 2? So here, please watch. All right. Now, again, this is the critical part. So please watch here for a quick second, because I don't want anybody to make this mistake again. It's the most common mistake. So what I want to do right now is I'm going to draw the base. So this is the base here. Stay with me, please, and watch what I'm doing. All right, that is the base. Now, how did I know that's the base? Because if I move this, this fits right in the back. Do you see that? All right, so if I copy that, so if I do this, you see that better now? All right, now what am I trying to show you? I need the distance between those two. You see how it's 2 now? All right, so again, guys, this is how I'm trying to explain it. That right there is 2. The length from here to here is 2. From here to here is 2. All the way around, that length is 2. That's the distance what I'm talking about when I say the distance between the two bases. All right, so now one more thing. I'm going to grab this and move it down. Hold on 1 second. All right, so now I move that down, and now I'm going to put times 2 here. Now, the reason why I'm making a big deal here is because I don't want to do all of that on the calculator. All right, that's too many parentheses. All right, too many parentheses. But I still want everybody to try that. All right, for example, you shouldn't do 4.5 plus 6.5 on the calculator. What is 4.5 plus 6.5? 11. Everybody should be able to do that. 4 plus 6 is 10. 0.5 and 0.5 is 1. 10 plus 1 is 11. And then you can say, well, 11 times 3 I know is what? 33. And then for some strange reason, if you don't know what half of 33 is, I don't care if you use your calculator on that, but you should know that's what? 16.5. You should know that. So 16.5 came from our mental math here. All right? Now, this one I'm not expecting you to understand so much. All right? 4.5 times 1.5 times 1/2. Somebody do that for me. And that was what? Hello? You're not... Come on, guys. That's what I'm talking about. You're not waiting for the answer. You are typing it in yourself. I said, what is 1/2 times 4.5 times 1.5? And some of you just sitting there. What is it, Angelina?
3.37.
I believe she's correct, but of course I'm not going to take her word for it. That's why I'm asking everybody to do it. And what is it? Is that correct?
Yeah.
All right. So now we have to add those two things together. And then after you add them together, you multiply by what?
2.
Multiply by 2, and that will tell you what the volume is. So what?
39.75.
Somebody said 39.75, but that's still not quite correct.
23.25 meters squared. Yeah.
Meters.
Meters cubed.
Meters cubed. Right, because we're measuring volume. Volume is 3 dimensions. All right, now Tucker, go ahead. Sorry. Are you disagreeing?
Yeah.
That's good for you to disagree.
23.25 meters cubed.
Okay, so now a lot of times what you did probably is you probably didn't hit the equal sign before you multiplied by 2. And then your calculator did 3.375 times 2 and then added 16.5. You should have done 16.5 plus 3.375, then put an equal sign. Are you hearing me?
Yeah.
That's what I'm telling you. If you're not doing that and you're not making a mistake when you take your test, that's when you make your silly mistakes. That's what I'm trying to tell you. That's why if you're wrong, you shouldn't sit there and go, wow, I'm wrong, and let me go on. You should let me explain to you why you're wrong, then you can make an A on your test. All right, simple as that. Yes, ma'am. Okay, go Acolyte. All right. Now, because I'm basically at the end anyway. All right. So now I want this, guys. Your job is to finish this up now. All right, that's your homework. Finish it up. Write the formula, plug the numbers into the formula, and then use your calculator to solve it. All right, tomorrow I think, or on Monday, I think we have cylinders. If you know how to do this, the cylinders are easy. All right. Please get to work now. Try to finish it up. I don't want you to have a whole bunch of homework. All right. Again, remember, Sean, you're writing the formula, plugging the number in, and then giving your answer. All right. If not, you get a 0 tomorrow, and then I call your parents. All right. That's the deal. Write the formula, plug the numbers in, then use your calculator. No classes tomorrow. Tomorrow's service day.